In this video, I'm going to show you how to create image collection, mosaic or composite and easily using Google's engine. Let's get started. So first, let's go to the website tutorials.gmap.org, and then from here, select image collection, reducing image collection. So this is the example we're going to use in this video. And so in the previous video, we already talked about how to get started with Earth Engine image collection, how to filter image collection by location, by attribute, and also by dates. And so in this video, we're going to base on the previous video to create basically image composite for any location. So it can be a city scale, it can be a country, it can be at the global scale. So this is how you can actually really to see the power of Google's engine. So compare with traditional approach using desktop remote sensing, that you need to download the imagery and also need to process the imagery locally. And if you're doing for larger scale, it's just basically impossible for using desktop resources using your personal computer. But using Google's engine, you can do it for any location, for any kind of a spatial and temporal scale. Okay, so let's get started. And first, let's download the notebook example to our computer. So you can click the download icon, and then you can save this one to any folder within your computer, and just hit save. After that, we can open Anaconda prompt. If you haven't installed Anaconda, you can follow my previous video how to install Anaconda or Miniconda and Gmap. Once you have installed, you should be able to have Anaconda prompt on your computer start menu, and just click. After that, you need to activate the Conda environment. So Conda activate. We already created the environment GE last time, so we're just going to activate the environment. Then you can type Jupyter notebooks. It should open your browser, and you'll be able to see the Jupyter notebook interface. And we just need to navigate to the location, okay, GE. Then we can open this notebook example, reducing image collection. So we're going to go through this example one by one. And so here you have 4 subsections. You can see this one here, the table of content. If you want, you can also directly open this one using Google Colab. So if you don't have Jupyter Notebook set up on your computer, you can you're welcome to open this one directly within Jupyter Notebook. But make sure that you have signed up for an Earth Engine account. Otherwise you won't be able to use this one. Okay, so first we're going to create an interactive map. So import EE and Gmap. After that, you can just use gmap.map to create an interactive map. And this is right now an empty map. You can zoom in, you can zoom out, you can turn the layer on and off if you want. You can also change the opacity. Once we have the map, we want to add some data. So in this case, we are going to create a so-called median image. What does this really mean? Is that for image collection, they are basically they say here around San Francisco at any time during the year, there's a Landsat overpass, like here, and we're going to use Landsat 8, right? And you can filter by location and by date. Basically, we're telling Google Earth Engine that okay, we want Landsat imagery for 2014 and the entire year, and we want to find out all the imagery. So because Landsat, the over revisit frequency is 16 days, so basically every month you're going to get roughly 2 imagery. So if you see from this one here, you might get roughly from 18 maybe to 24 22 imagery for the entire year. So keep that in mind. You can you need the image collection ID. So image collection basically just a folder. Think about like within your computer you have folder. Within that folder you have a stack of images, you have a bunch of files, and what we are trying to do here is to filter out to find imagery that belong to this specific location and also the specific time period that you specify. Also here at the end here you see a backslash. This is basically using Jupyter Notebook. if the statement doesn't end, if you go to the next line, you need to make sure that you put this one so that you will continue. And Google Earth Engine basically is just like you can think about just like a building blocks, like you can build on top of one on top of the other. So it's basically a chain of operations. You do this one and then dot until you get whatever you the result that you need. So image collection lane set 8. If you don't know the image collection ID, you can click the icon here and then data. So from here you should be able to search any data set. So in this case, I'm going to search, for example, lane set 8. Hit enter. It should show you the list of lane set data available within the Earth Engine data catalog. So this is right now, I think, more than 35 petabytes. So 1 petabyte is 1000 terabytes. So more than 35,000 terabyte of data. And for lane set 8, most likely you're going to use, for example, surface reflectance or top of atmosphere. So for example, if you click this one, and then you should be able to see the date. For example, this is the most important one here, is the image collection ID. This is basically the unique ID that we can use to filter the images. Think about the name or social security number of each individual, right? Once you have this one, you can get all the information for this specific image collection. You can see also the overview. You can also click the link here to go to the Earth Engine webpage to know more information. So all the image collection, you're going to have a description and what kind of spectral bands available within the imagery. You can also see some of the image properties, right? This is how you can filter, for example, by cloud cover or by date or others. Okay, and you also see the JavaScript example. And because we're using Python, if you using this one, you can open in the code editor if you want. But if you want to use that with Python, you can simply copy the code, and then you can come back to here, the notebook example. We can click the toolbox, and then click this one. Probably this one is not updated yet. We might need to anyway. I will show that next time. But for now, let's just continue with this example. So in here, we are trying to filter the lane set 8 image collection, and we're gonna filter by this is the so-called WRS pass and road. It's basically the lane set 8 footprint. So we want this specifically cover this one. You can also filter by location, so it doesn't have to be using this way. You can filter by date, also filter by location. I'm going to show you in the next example how to filter by, for example, coordinates or a polygon. Okay, so once you figure out, for example, the entire image collection, right, and then we can see how many images actually within this image collection. Think about the time series of the images for 1 year. You are going to get from 15 to maybe 20, 22 images, and all you need to do just to apply this one. So once you have all the images, you can apply the function called median. Once you apply the median, it becomes an image. So basically, think about here, every location, every pixel is a series of image values, and if you apply the median, basically you just take the median value of that series. And if you use a remote sensing for cloud, most likely the value will be very high. So cloud is appear as white color, bright color. So if you take the median, most likely most of the cloud pixels will be gone, right? So it's the easiest way to create cloud-free imagery using this example. And once you have the median image, then you can show the image, and then you can apply this one to show it on the map in here. So quickly, right? So this is what it looks like. And if you navigate Google Earth, most likely you also see image like very clear, but in reality, those are not the original landscape imagery, because you're going to have a lot of cloud. Right now, even in here, we use the median, you still see a lot of cloud actually in here, especially near the ocean area. But the land area looks pretty good. All the cloud has been pretty much removed, right? So you can zoom in, you can zoom out, you can inspect the values. Okay, so next I can quickly show you, for example, once we create a median image, you might want to see, for example, how many images were used to create this one. So you can use the collection, right? And then doc size, doc get info. Again, in Python, you need to have the doc get info in order to look at the contents within this server side object. Okay, and so all need to just execute 19. This is within our expectation. As I mentioned earlier, Lancet has revisited frequency of 16 days. So every month you get roughly 2. Maximum you can get 24, right? So 15 to 24. And this is the normal within the normal range. You can also see, for example, what's the image ID for each individual one. So in the previous video, I already showed you how to use the aggregate array. So aggregate array, you can think about like it's a spreadsheet, right? Within each column, you can aggregate to get just the series of values for that column. So let me just execute this one, and you can take a look. For example, these are all the image ID, right? So this is the image collection ID, and then within that collection, you have each individual image. And the last 8 digits here, this shows you the date, right? So 2014, January 13, all the way to 2014, December 31st. So this is all the imagery. You can also show the cloud. For example, if you want to see like the cloud coverage for each imagery, you can do that as well. So I'm going to create a new cell below, and I can simply just copy this one and then paste. All you need to figure out is the property. So this is one of the property. If you want to know more, you can go to the web page, and then, for example, image properties, and you can look at this one, for example, cloud cover. So if you want to get all the cloud cover for this image collection, you can just simply paste this one here, and then Alt Enter. It will show you all the cloud cover for this specific image collection. So, for example, the first one is just 14.14%. So this is a good image. The second one is really bad, right? You can see this 90% of the image has cloud. If you really want to see, for example, that specific imagery, you can do that as well. So let's say we want to look at the second imagery, because the median imagery that we created, this is already aggregated from the 19 images. So basically try to choose the base pixel. If you want to see, for example, the maximum, the median here is a good one, but you can also use the maximum, a median, or you can also do a mean. We will show you the examples later. But for now, let's show you, for example, you have a bunch of images. You want to see a specific one, can you? Yes, you can. So I can, for example, image equal to, and we know this is the collection, right? In order to get a specific imagery, if you just want to see the first one, you can doc first, and then from here I can just map doc add layer, right? And then image. If you want to customize the parameters, so we're going to use this one in here, and come back to here, just paste this one. This is how we're going to visualize, and I can say, okay, first image, and then I just want to show the image. Alt Enter. You should be able to see this one, right? And I can turn the median off. So this one is the real raw data, original image, and you will see this is the very nice image, because the cloud cover is very, very low. So if you're trying to select one image, you can just directly use this one. But if you're doing analysis for a larger scale, sometimes it's difficult to pick all the imagery that with not much cloud cover. So this is the way that we want to use. Similarly, if you want to get, for example, the second imagery, you cannot use the second. There's a function called doc_second. You need to convert the image collection to a list, and then convert it back to an image. So I'm going to show you here how you can do the second one. For example, I can say second equal to the collection. Doc. You need to use to list. Okay, doc to list. Okay, and the to list, you need to figure out how many images you want. So in this case, if you just want the second image, you can just put 2. It's fine. But if you want to indexing all the images, you need to put like this one. You can do collection dot size. dot size. That means we want to convert the entire image collection to a list, and we want to use all of them. So let's say you have 1,000 images. If you just want the second one or the third one, you don't need we need to convert the entire one like 1,000. You can put the number you want, but in this case, I'm just going to put the entire image collection. So the size will be, like I said earlier, it will be 19, right? And then once you have this one, you can use .get. .get means within this, we want to get the second one. So in Python, the second one is actually 1. It starts from 0. So the 0 is the first item, 1 is the second item. So in this case, we want the second imagery. So that's why we use the index 1. And after you get this, it is an item, and you need to actually convert this one explicitly into an Earth Engine image. So what we need to do, Earth Engine image, and then wrap this one, so parentheses, and then put the one at the end. So in that way, right now this one becomes an Earth Engine image. And then what we want is to actually copy this line and then come back to here, so you can change this variable. So now we are adding the second imagery. And second, as you can see earlier from the cloud cover, so we want to expect that this one has high cloud cover coverage, because 90% is going to be cloud. So if we want to add this one, okay, so this is exactly what we're expecting. This second imagery has a lot of clouds and more than 90%, so it's a very bad imagery. Similarly, if you want the third one or the fourth one, you can do that easily just using one line of code. So again, if you want number 4, then what you need to do is to change this one to number 3. So always -1. So -3, and you can change the name of the variable if you want. Okay, so but I'm just going to simply execute one more time. You should see a better imagery. Okay, so this is the nice imagery because the cloud cover is pretty low, right? So only 0.05%. And in terms of the imagery in here, this is probably one of the best, right? So you want to look at the smaller number. Okay, so this is how you can filter the imagery, image collection by, for example, by a specific location, and also how to do the indexing to get one imagery. So again, we have 19 images within this image collection, but you can use this to indexing to get one specific imagery. And you can just simply use the median function. So this is the one of the very common one that you use with Google's engine, is that it doesn't matter how many images you have, you just stop median, and then it will take the median value of each pixel, because each pixel has a time series of images, right? Values. So you take the median, most likely it will be cloud free. Not always the case, but it's the easiest way that you can create a cloud free imagery. Similarly, you can also use the so-called reducer. So in Google's engine, reducer basically is to reduce in spatial and temporal dimension. So if you have a bunch of images, if you want to collapse those into one image, it's called reduce. If you have like a bunch of attributes and you want to, for example, get some statistics for a specific attribute, then it's also called reducing something. So it's called reduce. And so in Earth Engine, there are a bunch of reducers. If you want, you can go to the Earth Engine, and for example, once you log into your account, you should be able to see the documentation, and from there you can scroll down to look at EE.reducer. So here shows you a bunch of these in here, and the one that we're going to use is called EE.median. So right, so the median is this one. You can also do mean or max or minimum. You can also do sum. So there are a lot of things you can do using the reducer. Depends on the specific in what you want, what you're trying to achieve. So this one here, this block of code is the same as the one we used previously. But this one here, you don't use .median. You can use .reduce, and then what you're trying to reduce is basically what you're trying to do. You can use the e.reducer median. You can also do minimum or max or mean or standard deviation. So it's up to you. But one difference is that if you use the reducer, the band name is going to be changed. So it's going to append the so depends on the reducer. For example, if it's median, the band name is going to be changed to underscore median. We can go back to the previous one here to show you the band name. For example, median. If you want to see the band name, you can say median dot band names, and then dot get info. You should be able to see from MEDI. Okay. So if you use the median function, the name is still the same as the original image collection. But if you use the reducer, the band name is going to be changed. So let's just execute this one, and basically the result will be the same as the previous one. But we're going to use this one here. If you use this again, median dot band names parenthesis dot get info, and then alt enter. You will see right now the band name is slightly different. So this is like the name and then underscore median. So just to keep that in mind, because when you try to visualize the imagery, if you need to provide the band, for example, B4, B3, B2, make sure you provide the correct one, right? So this is the imagery that we have. Again, you can change this one, for example, to minimum max. Let's say try max and see what happens. So you don't really have to change the name of the variable. It doesn't really matter. But if you use max, this one probably need to be higher, because otherwise you might get just a white imagery. Oh, we also need to change this one. Okay, so it becomes because the bank name right now probably is B4 max. Similarly for this one, I need to change to max, and this one also to max. Then if you want this one, you see it's pretty much a white color, because if you have a series of pixels and each pixel has a number of values, if you're trying to get the max, most likely you'll be cloud, because cloud is bright color, and this is use this. So normally you don't use this to create cloud free imaging. Similarly, you can use min if you want. It might be similar to the median, but not always the case. Min, if you have high value, you're still going to end up with high value. So if I change to, for example, min, MEAN, and let's take a look. Okay, it's better than max, but still, this why you see still like high value. This is still a lot of cloud. So the best way is actually to use a median, and you can also use percentile. You can customize if you want, but in this example, we're just going to use the simple median. Okay, so lastly, I'm going to show you the other one, how to create image composite for a specific location. It can be a state, a county, a country, or city. So this is how you can really see the power of Google's engine, because the location, the region doesn't really matter. As long as you know what you want, you can simply just using a free line of code to create a cloud-free imagery for a larger scale area. And we are going to use the census data. So the census data, we're going to, let me just show you in here. So let's execute and then add the data layer. So the census data for the United States. So you can see we have all the polygon in here. Again, if you don't remember the image collection ID, it's fine. You can just come here, click the icon, and then from here data, and you can just search census, hit enter, and then you should be able to see the list of census data. And we're going to use a census state 2018. Once you select this one, you should be able to find out the image collection ID. So this is how you can refer to the data. You can also click the import, right? Click the import, and then it's automatically create a new cell block. Then you just execute. So you should be able to add the data to the map. Once you have the feature image collection, then you can do the filtering. So in this case, we just want to select California out of this image collection. So and what you can do is that you use the filter. So we already talked about filtering in the previous video, getting started with Earth Engine image filter collection. So you can check out that video if you don't know how to do the filtering. So this is basically just select by attribute. If you want to know what kind of attribute the filter collection has, you can click this one and then click on the map. So let me turn off other data layers. Since we don't need those data layers, so we just keep this one, and then you can click on the map. Once you click on the map, it's going to query the data. So for each specific location, basically intersect the point with the polygon, right? So in this case, we're clicking on California. So California, it has this all kind of image feature collection properties. So we're going to use this one, name, and then California. So in this way, we can just select one specific polygon out of the entire state polygon. So name California. So come to here, right? So this is the feature collection, and then we're just going to filter by attribute. So the attribute we're going to use is EQ, means equal. So if something equals to the name equal to California, then we select this one, and then we add the layer to the map. So you can just execute, hit run, and then come back to here. You should be able to see this one in here. So we can simply click this one, we can uncheck. So now we only have this one, California. This is how we can do the select by attribute. Once we have this one, we can create imagery just for this specific area. They say we want the imagery for landscape imagery for this state in 2020. So think about in the past, if you have to go to USGS to download the data set, right, one by one, one piece by one piece, and then mosaic them together. You also need to select the base imagery cloud free. It's going to take you many hours to do that. So but using Google's engine, you just need a couple minutes, and then you can create the imagery easily. So next, then let's show you how to do that. Again, we're going to use the same image collection ID, right? Landscape imagery, and then you can filter. So filter bounds, basically filter by location. So the bounds we're going to use is basically California, right? Because we already filtered this one out. And also you can filter by date. The start date is the 2020 January 1st, and the end date is 2021. Keep that in mind. The end date is not included. So so if you want the entire year, you also want to basically add one more date, because this one is exclusive and this one is inclusive. So, and what we're trying to do here in this code block is that we want landscape imagery for California in 2020. So give me all the images, and take a look and just execute, so we can see how many images are in there. And you can use the collection doc size and then doc get info to see how many images. Okay, so it's 803 images for this we covering this area in 2020. So it's a lot of imagery. If you're trying to download, it's going to take you a while. After that, this is the magic, where the magic happens. So let me delete this one first, just to show you what. So this one is similar to what we did earlier, right? You have all the images. You just apply a function called median, and then you get the cloud-free images. So run, and let's take a look first to see what happens, right? We can show the map in here. Just hit this one. Okay, so as you can see, it's going to create all the imagery and then mosaic them and use the apply the median function, and it still look pretty nice, right? But it's being covered by the it's not clipped to the state boundary yet. It is basically just all the area intersecting, all the imagery intersecting this area. You can zoom in, you can zoom out, right? So this is so easy. Just one line of code, you can create a cloud-free imagery for a state. You can do that for the entire US if you want. So I'm just showing you how to do that. You can also do it for other countries, as long as you know what kind of polygon you want to provide. You can also provide a geometry. You can also draw a polygon. I'm going to show you later. But next, we also want to use dot clip. Clip means we want to clip to the boundary. So in this case, we want to clip to just the boundary of California, you can do that as well. So just dock, and then we can run this one again. You should be able to see this one right now, exactly within California, right? So again, you can change to other location. You can do whatever location you want. It's going to be much easier compared to download imagery for others. So let me see here. For example, I can do that for Texas. So all you need to do, come back to here, and then I can just change this one to Texas. So and run this one more time. You can just select this one and then say cell run all below. So it's going to run all the cell below, and just re-execute. And it might take 20-30 seconds. You should be able to get the result. So this is how powerful it is. You can do that for any location, any country, or any state, any city, without having to change a lot of things. You don't need to rerun, re-download things on your computer. What you really need just to figure out, for example, what's your area of interest, and also what kind of imagery you want, right? So this one has slightly more, 954 imagery, and now you have see this one here in Texas, right? So we can come back to here and check the imagery and set 2020, right? So you have all the images for Texas. Again, it's not perfect because if you have a lot of cloud, you're gonna still see something like that, but it give you a nice imagery, like without much effort. You can still create something like this easily. Okay, so this is how you create a image composite for a specific location. Besides providing, for example, by state, you can also draw a polygon. So I can say, let's see here, I can zoom to any other location and I can create imagery like that. So for example, they say in here, and if you're interested in basically river dynamics, and you want to see the river dynamics in 2020, you want to create a free imagery, you can do that as well. I can just come here and then maybe draw a rectangle. So it's going to create imagery. This is one small area, so it might just be just one or two images. You can also expand a little bit if you want. So let me delete this one first. I can draw a larger area, so I can maybe do this one, and then draw a larger polygon. So once we create this one becomes a user ROI. So you can use, for example, map.user ROI, and this is basically a geometry, and you can get info to see the coordinates, right? Then we can use this one to filter the image collection. So it'll be the same, just like this one in here. So what we need to do is just copy this line of code and then come to here. What you need to just change this one. So this one right now we are filtering using this ROI. So you just need this one, map.user ROI, and then you can hit Alt Enter, and then collection dot size dot get info, and then Alt Enter. 175, right? So this is because it is a smaller area, so less imagery. Again, then you can just create the median image. So I can maybe image equal to collection dot median, and we have the median imagery. Then you can visualize the data. So you can map.add layer, and this is the image, right? So you can visualize the information, and I can say this is like improve 2020, right? Alt Enter, and you have this one. This area is has a lot of cloud, so the imagery quality might not be very good, but you can also change the way how you want the mosaic. I'm just showing you the example how you can create this. You can also use this one, median. You can also clip, right? Dot clip, and then clip to the location. Again, it's just the map dot user ROI, and then shift enter. It should just create the imagery within the specific location. There's a missing piece here in the upper right corner. Anyway, so this is the way that you can filter the imagery by location, and you can use the median function to create image composite, and based on a stack of images. And so this a good way that if you want to quickly find out some imagery and then create some mosaic for specific location without having to download data to your computer. Okay, so that's all for this video. I will see you in the next one. Take care. Bye bye.